Yesterday we talked about all this factoring. We're going to keep with the factoring. I'm going to show you a couple shortcuts, a couple special patterns. I've already showed you two little special tricks throughout your homework. Just to recap, if the leading coefficient is 1, let's say I had x squared.
That minus?
So you spaced out. Okay. Let's say I had this. If the leading coefficient is 1, it only works when the leading coefficient, LC, is 1. Okay? Then the two factors that multiply to -6 but add to 5.
If you were going to put on pants, why would you do this?
No, I had gym and I didn't want pain.
That's cool. All right.
Which are what? What multiplies to -6 but adds to +5?
6 and -1.
6 and -1. Do we all agree?
Yes.
Okay. Because the leading coefficient is 1, I can just go straight into x plus 6 and x minus 1. If that leading coefficient is not 1, it does not work. If you do not want to remember that and try to remember when it works and when it doesn't, then you can always group. Group works in every situation. Okay?
So now it's our homework,
Yes.
right?
No. All right.
What's the homework?
Special pattern number 2 we've already talked about. It's called the difference of two squares. If I have two perfect squares separated by a subtraction sign, some of you already have this in your notes because I did it. I gave it to you whenever we were going over homework. But just so it's in the video as well. A minus B, A plus B. So an example, give me a perfect square. Somebody give me a perfect square.
4.
16.
4.
That's 16.
Give me one that's not a power of 4.
25.
121. 2x minus 5. 2x plus, is it this? Oh, not 5, 11. I heard 25, I wrote 121, and I'm factoring 25. Losing my mind today.
I'm multitask.
11.
Listening to this lesson.
Your mom.
Factoring, special patterns, resolving. Your day.
Why did you put 5?
Why did you put 5?
Gosh knows. I don't know.
Wait, so
Why
why
is
do
that
you have
plus?
to do 2? Oh, I got it.
That's the
Can
pattern.
we do 2x plus minus
right.
11 instead of write 2?
No, you got to write 2.
So what happens? Okay, say it was.
Robert.
Or could we do, oh, never mind.
All right, pattern number 3. You have to memorize this pattern because we're going to get to a section, 2 sections from here, where you're going to have to know this pattern inside, outside, backwards. Dylan put that up. And if you don't, you will not be able to complete the square. So I really, really, really need you to learn this one, okay? Good.
In a
Perfect square trinomial, also known as a PST. I will call it sometimes, okay? Not PTSD, PST for perfect square trinomial. All right, 3 things about, you got to be able to recognize them, okay? Trinomial means 3 pieces. There are 2 types of perfect square trinomials, that's why I'm doing 2. All right, the first one and the last one have to be perfect squares. The second sign has to be a plus. So maybe this is requirement number 1. Requirement number 2. And the third requirement is the hardest to see. The middle term, and listen carefully, has to be double the product. Product means what? Multiply. So double the product of the square roots of the ends.
That's hard.
All right, think about that for just a minute. Double the product, so double, so 2 times something, right? Double the product of the square roots, and we already said they're perfect squares, so A and B of the products of the ends. Okay, so this has to be 2AB. Double the product of the square roots of the ends. It's a mouthful and it sounds like a lot, but you'll start to recognize them very quickly, okay? That's got to be the third requirement. Again, the hardest to see because you will have a lot that aren't doubled. They'll just be the product of the square roots of the ends, and you'll have to know, stop, that's not a PST, okay?
Pieces.
The first sign can be either plus or minus. Once you recognize that it's a perfect square trinomial, it meets those three criteria, the factoring is easy, okay? To factor this, it's the square root of the first, the very first sign, the square root of the last, squared. That's how it factors, yep. You can still group it. It will group and it will factor perfectly for you. But PSTs, the values on the ends can get very large, and then when you multiply them together to try to find the two numbers, it can get quite sticky because it can be really big. Okay, so I'm going to show you several examples, a couple examples maybe. All right, so let's say, you tell me yes or no, perfect square trinomial.
No,
No,
Why?
because 20 is not the second power.
25 times, wait.
2 times 5 is 10. It's not doubled. To be a perfect square trinomial, it would have to be 2x times 5, which is 10x, and then it would have to double to be in the middle. So for this to be a perfect square trinomial, I would need it to be 4x squared minus 20x plus 25. Now it is a perfect square trinomial.
I'll leave it use that right
So how does it factor?
Minus plus 10. Plus
Squared. That's it.
A times B. Wait, no. A. So it's
We're not doing what we did.
times C
Is 100.
plus B multiplied and doubled to.
Right, okay, yes, but the square root of A and the square root of C.
How would we get, like, that if we didn't do it this way?
If you didn't do it this way, if you multiplied A and C, what multiplies to 100 but adds to negative 20? Negative 10 and negative 10. So then you'd have 4x squared minus 10x plus 25, 2x times x minus 5.
So you get the same thing as that.
Oops, that's a 2. You get the same thing. You get 2x minus 5, 2x minus 5. But we're going to be completing the square soon, and you'll have to be able, that's why I really push perfect square trinomial rather than doing it through grouping. Did it just cut off again?
You know. Factor out 4x squared minus 6.
No. It will not factor. All right, let me show you one more.
Wait, so what if it does factor?
What you mean?
Like a perfect trinomial that does that.
This does factor.
I mean,
You mean it's not a perfect square trinomial, but the middle, like this.
like, no, like they're all, you can take 2 out of every one. What do you think?
Oh, yeah, you can do that.
And then
You can do that.
you still solve each
Mhm,
one.
yeah. All right. Tell me what you think about perfect square trinomial. Easy, hard. All right. I'm going to leave that there for just a minute because there's one other, several of you asked me, Dylan,
Take it. That's the
I wasn't even,
Give it to
I was being
Huff.
quiet.
Give it to Huff Daddy.
I was being quiet though.
That don't
You
matter.
get this Huff.
I feel like if you have an A in this class, you're lucky.
Exactly.
What job
I
you
have
work
a 9 now,
now?
so.
That's so stupid.
Avery, you gotta get an A.
this one is going to impact us whenever we start solving and finding the zeros, so I feel like I need to mention it. I've not usually done it when we factor, but I think I will. Luke.
Holy cow, Lewis.
The males in this class are so
Yeah.
Luke, you
Make him stand up. Luke, stand up. Make him stand up.
And make him stand up.
Guys,
Stand up.
I love how y'all try to run my classroom. Okay, here's what we do when it's a sum of two cubes.
Robert, aren't you a male? I think.
I am
He's an it.
the straight male in this class.
There we go. There's the factor pattern for it if it's the same.
I thought you were.
It's an imaginary solution, and you'll see why in just a second. Yeah. Yeah, that was the 33 that I told you to leave out because I didn't want to show you just yet. All right, we'll talk more about that in just a minute, but if you see it with a plus in the middle, know that there's an I involved.
No.
Yeah. For real, for real. For real. For real. For real, for real.
Like for real, I'm gonna.
Is that
Oh,
36?
Rizzle?
Like literally?
Okay.
All right.
Don't put me on.
Let me talk about solving, and I'm going to come back to these, okay? Remember, we are still in the section from yesterday. We have still not gotten through everything. This is a loaded lesson, I think. Definitely needs to be 2 days at a
Is this the
minimum.
hardest lesson?
No, but it's a very fundamental lesson.
Homework quiz
What is the
tomorrow.
hardest
All right,
lesson?
solving. We touched on this yesterday, but since
Can you get back?
If I equals 4 negative 1, I want to.
guys, all right, solving. We talked about this a little bit yesterday, okay?
Are we still in this chapter?
Yeah, yeah. All right, so the point in factoring is so that we get this quadratic broke down into 2 pieces so that they're multiplied together. Because like we said yesterday, if you multiply any 2 things together and they equal 0, then it follows, it just makes sense that one or both of them has to be 0, right? If I let A be 0, my equation is satisfied. If I let B be 0, my equation is satisfied. So that's what I'm doing with factoring. I'm getting these 2 things multiplied together. I'm going to let them equal 0, and I'm going to solve from there. Okay, so what I'm finding is I'm finding the zeros, and I'm just running through this. If I need to slow down, tell me, because I mentioned this yesterday. If I have an equation, this would have been if x squared minus x minus 6. If that were my equation, okay, and I said find the zeros. The zeros are where it crosses the x-axis. So to find the x-intercepts, I would let y be 0, and I would solve for x. And I don't know how to solve that unless I factor, okay? So by factoring, it gives me these 2 multiplied pieces. And since I know that to get 0 when I multiply 2 things together, one or more of them has to be 0, then I say, okay, x plus 2 must be 0, or x minus 3 must be 0. So I know that whatever else this parabola is doing, it is crossing the x-axis at -2 and 3, correct? Okay? So solving just is simply making it equal 0, factor, and set each piece to 0. Okay? Yeah, because that's what you're looking for. You're looking for single x values. So let's do a couple, and then we're going to go backwards with it. I'm going to give you the zeros, and you're going to write the factored form for me. Okay? All right.
I plug in the whole thing on calculator to let me
Did we ask?
Why can't we do that?
Why not? Who asked?
Let's show work, so.
Let's do...
It's 10:54. We leave in 5 minutes.
No, we don't. Shut
We
your
did that
mouth.
Starbucks meeting today.
Y'all,
All A on roll. Oh, wait.
all right, so I want to make sure it equals 0 before I start, okay? The directions just say solve for x. But if you think about it graphically, what I'm doing when it equals 0 is I'm finding the x-intercepts of the zeros, okay? All right, so first thing I want to do is factor completely once it equals 0. This is an easy factor. Why is this an easy factor?
Because 7, 9, what?
The 1. I'm at the coefficient.
Yep, the leading coefficient's 1. So if I can find what multiplies to -28 and adds to -3, I don't even have to group or do any other method. 7 and 4. Which one's negative?
7.
7. How do you know to make 7 the negative one? It's got to add to -3. That one's negative, so you need your biggest factor to be negative. All right, so I get
X
x.
minus 7, x plus 4.
Is anybody confused? How do I solve it from here? Everybody always gets the solving part. That's the easy part, everybody thinks. X equals 7.
And X equals -4.
What do you notice about the signs of the zeros and the signs of the factor? They're opposite, right? So how about this? Write me the equation of a quadratic that crosses the x-axis at 2 and -7.
So it'd be -2.
X minus 2, X plus 7.
That's exactly right.
You just flip the sign.
Does that make sense? Write it in standard form.
Oh, really?
What does standard form mean?
AX plus BX equals C.
How do I get this in standard form?
Boil it. Alright, that's enough.
Easy?
Yep.
I think that's all.
Is that it?
Let me do one more. Let me do one more.
Wait, it's not.
Let's do the one you said we were having trouble with. Oh, let us try to solve it at first, don't say anything.
Miss McGee, you're my black.
Okay. Solve the equation.
For what?
I need the green.
There's only one variable there, buddy.
For X.
For
Okay,
X,
I got
for
this.
X.
Hey, yo,
Yes,
what's up,
solve,
man?
solve,
Hey, yo,
that,
stop.
solve that equation for
I'm not with that.
X.
Allison, get your girl, yo. I'm not playing with her. Is that?
And 1.
No,
9 and 1, 1.
no.
9 and something.
There is none.
Yes, there are. There are 2 real zeros in this one.
9 and infinite.
X is negative 9 and 0.
Exactly right.
Wait, what did you say?
0, that's what I had.
0 and 9.
Oh, wait, one of them has.
Most of you got that you pull out the X. Okay? I can't factor it any further. I have 2 things being multiplied together, thing 1, thing 2, to give me 0, which tells me that this one must be 0, or this one must be 0.
Exactly.
That was an easy one.
Oh, yeah.